So let's start graphing the parent graph of rational functions 1 over x. Okay, rational functions, the parent graph is 1 over x. So let's give values for x and let's solve for y or f of x. So let's start with -4, -3, -2, -1. Okay, let's start with these numbers. So we will make this our denominator 1 over x. So that's 1 over -4, 1 over -3, 1 over -2, and 1 over -1. So that's just -1/4, -1/3, -1/2, and -1. Let's plot these numbers, okay? So when x is -4, 1, 2, 3, 4, that is -1/4. Very close to 0. Then as we go to the right, -3, it will become -1/3. So it is decreasing, okay? And -2 will become -1/2. -1 is -1. Okay. Let's study what will happen if x is 0. If x is 0, what is 1 over 0? Okay, that is undefined or infinity. So 0 is not part of our domain. But you ask yourself, when will y be 0? Or f of x be 0? F of x will never be 0 too. Okay, so 0 is also not part of our range. So let's just study what happens in this area around here. So let's just give -1/2. If x is -1/2, what is 1 over -1/2? I hope you know your fractions. That will be -2. -1/3. What's 1 over -1/3? That's just -3. Okay, so I think you see the pattern. So when x is -1/2, -2. As we go closer to 0, okay, as x approaches 0, y approaches 0 also, okay? So we're getting closer and closer there. So one important thing in rational is it has a horizontal asymptote on x equals 0 because we are approaching that number. And it also has a vertical asymptote on, this is x equals 0, the other one is y equals 0. So that is, okay, so let's graph it a little bit here so you can see it a little bit to the right. So rational functions, the graph of rational functions have a vertical asymptote at x equals 0 and a horizontal asymptote on the x-axis or y equals 0. Y-axis, x equals 0. Okay, and the graph will approach your asymptote, okay, closer and closer, but never touching it, okay? So that is one part of it. Let's go to the positive values. Okay, let's just start with 1/3, 1/2, 1, 2, 3, 4. So let's get the reciprocal of this, or 1 over x. So 1 over 1/3 will give you 3. 1 over 1/2 will give you 2. Okay, and 1 over 1 is 1, 1 over 2, 1/2, 1/3, and 1/4. Okay, let's plot these values. So when x is positive 1/3, it's 3, 1, 2, 3. 1/2 is 2, 1, 1, 2, 1/2. And then we are now getting closer to 0 again, okay? So this is your graph. We will approach the two asymptotes. Okay. So to simplify this, we're just going to graph these three numbers. Okay, let's graph the -2, -1/2, -1, and 1/2 -2. And same thing here, 1/2, 2, 1, 2, 1/2. Okay, so we're just going to graph this, and then we will, so this point, and this. Okay, and also here. Then we will just use our arrows to tell our reader the behavior of our parent graph. Okay, so let's give a summary here. So we will just get the vertical asymptote. What is the vertical asymptote? Or let's shortcut it to VA. So vertical asymptote is x equals 0. What is our horizontal asymptote? Will be y equals 0. And what is our domain? Domain will be all real except 0, or -infinity to 0 parenthesis, union with parenthesis 0 to positive infinity. What is our range? Everything except 0. So range is -infinity to 0 also. Okay, so again, this is the parent graph, y equals 1 over x. Okay, so what do you think will happen? So again, we graph only these 6 points, and we get our x and y intercept. X and y horizontal and vertical asymptote. Okay, so what do you think? Let's transform this. What happens if I will put here a minus, let's say -5. Okay, -5. Okay, what transformation is that? So in the next video, can you just graph the parent graph maybe 3 times, and we're going to transform it, so maybe 2 on each page. Okay, prepare it, and I'll see you in the next video.